be learning about trigonometry. So what is trigonometry? Well, it's the study of triangles in a mathematical sense. As you can see here, we have displayed different types of triangles. Normally, when we're trying to deal with it in physics, you'd be going with right triangles. As you can see here, we have two different types of right triangles. One that is based on 30 degrees, 60 degrees, and having a major angle of denoted by this right square as 90 degrees. As you can see here, this is another right triangle that is normally present present a lot in trigonometric functions. That is a 45, 45, and 90 degree triangle. This is an equilateral triangle if you couldn't tell by equal angles as well as equal sides. So what you need to know in order to calculate in trigonometry? Well, you need to know sine, which is opposite over adjacent, cosine, which is equal to adjacent over hypotenuse, and tangent, which is equal to adjacent over the opposite side. Now you might be wondering, well, what is this in relation to? Well, it's in relation to a right triangle. As we see it seen over there, a right triangle is basically denoted by a right angle, or basically a small square at the bottom right or left, or wherever the 90 degree is. So what is opposite, hypotenuse, adjacent? Well, z here can be denoted as the hypotenuse, and normally you find that in right triangles. Also, what helps to denote in a 90 degree triangle is this, which is Pythagorean theorem, which basically states that the areas of a triangle, if you use each side of the triangle as like a side of a square, the areas that are present within both the one side and another side of the triangle is equal to the area of that of the hypotenuse. But that's something that you don't really need to know for now. But right now, all you need to know is that this is hypotenuse, these are the two sides, and all the angles within a triangle are equal to 180. Let's see. So I explained what they are, right? Is that?
Yeah. So just to remind people, the hypotenuse is typically a cross from the 90 degree angle. All right. Cool.
So you might be wondering to yourself again, what are degrees? Well, degrees are just a measurement of an angle. We typically use either degrees or radians, and radians are just in reference to a circle. And it's basically, if you know the geometry of a circle, there's the center point, which is basically 1/2 the diameter, or the radius. And a radian is basically just taking the radius and then taking a segment out of the circumference of the circle, or basically the whole perimeter of the circle, and just dividing it by the value of the radius. So as you can see here, a radian, which is denoted as theta, is equal to the subtended arc created by these two radii, or just the portion of a circumference divided by the radius of a circle. And normally degrees is in relation to 360 as a total division of a circle, and radians usually are denoted with using pi, which looks like this. Looks like a small hut. And every pi is equal to 180 degrees. And you can see here that is the conversion of radians to degrees, which is radians equals to pi over 180 times degrees, and degrees is equal to 180 over pi times radians. And that's basically it to understand the transition between one and the other. Normally we use radians because that's more accurate due to the fact that they can be represented as a fraction, and ultimately those are much more accurate than decimal places.
Oh, before you move on, do you just want to demonstrate a quick conversion between a radian and a degree, or a degree and a radian?
I mean, normally I would assume they would just follow that, and I think I would assume they'd also understand how to do it. Just do it. Okay.
Just for the camera's sake.
Just for posterity reasons.
Yeah.
Okay, so you might be asking yourself, well, how do we switch between degrees and radians? Well, let's say you have, what's a general number they can use in?
Like 60 degrees.
Okay, let's say you have 60 degrees. Now, degrees is normally denoted by a little small circle on the top upper right-hand corner. Now, what do you think we should do? Since the conversion is the degree multiplied by pi over 180.
I love how you're taking the audience to different places. It's an immersive experience here that we offer in ModIT.
We'll be in Vietnam.
Vietnam.
So now we have this value, correct? Well, let's just multiply it by pi, and you get 60
Lieutenant
over
Dan's by
180 pi. Now, believe it or not, adding in those units on the top and the bottom actually cancels out those units, and what you have is just regular 60 over 180. Now, 60 over 180 is basically 1/3 times pi, and that is your radians. That is quick and simple and dirty. Wow.
Pi 3 rads.
Hell yeah.
Okay.
Now, what is a common radical radian that you would like to use?
Like pi over 2.
Okay, let's say pi over 2. Now, let's say, pi over 2. I like that number.
Oh wait, do you
Let's
just want to add the word rads underneath pi 3 rads?
Rate.
Pi 3. Yeah. Gotta keep your units. Alright, go on.
Alright, so you want to say, well, I have these rads here, and I just want to...
You sound more like a damsel in distress. I don't know why.
So now you have this conversion, right? And now you wonder to yourself, what? Okay.
Wow.
So what you have to do is multiply. Now, if you know how to multiply a fraction, what you have to do is just add that little bugger in there, and boy, you got it.
Wow.
So now...
You got it, Navy Calculateral starring Justin Eng. Dun dun.
Please remove that from YouTube. Alright, so now we have it. You remove
Oh my god.
units and remove pi.
Unnecessary units, yeah.
All you have left is 180 over 2. That is 90. And
90.
that should be correct, because if you divide radian, or pi radian, which is 180 degrees, and you divide by 2, you get 90.
Cool.
So that makes total sense.
Thanks for demonstrating, Mr.
Yes!
Alright, let's have normal Justin back.
Whoa, okay.
Huh,
So
Jesus.
how do trigonometric functions and angle measures relate? Well, like we stated over here, you can basically try to figure out what tan, cosine, or sine, what their values would be like in relation to a triangle. Now, let's say you have this triangle, right? And you wanted to find sine of angle degree A. Well, since you have the opposite, which is x, and the hypotenuse, which is c, basically what you can do is you find sine of angle A is equal to x over c. Now,
So if you gave it numbers, what would it be?
let's see.
Like a 3,
Sine
4, 5
30
triangle.
Sine 30. So that basically be what?
Say that you're trying to find
I'm
A.
just trying to use just general terms so that I can just like
Okay.
say, you can just do this to find x, you can find z, and you also could find a.
Yeah, sure. So just to make sure that everybody understands that x and c represent numbers that you would see representing the lengths of the sides of the triangle.
Now, I'm going to go the long way just to show you. Ultimately, what you can do is you can set sine A is equal to 1 and cross multiply. And basically what you get is z sine A, sine of angle A is equal to x. And you can figure out what z is by just dividing, and you get z is equal to x over sine A. Now you think to yourself, wow, these are numbers, and I can figure it out, but what about angle A? Well, fret not.
Yeah, so Justin was just doing a bit of algebraic manipulation there to show you that if you're given a couple of terms and you need to find one, you can rearrange the formula in order to find and isolate the variable.
And now you're stuck with A. You already know, if you wanted to try this for yourself, go ahead. But if you wanted to know what x and z were, if you already knew what these two are, but you want to know what A is, what you can do is you can find the inverse of sine and multiply it to both sides. And this works all with any of these. If you find the inverse of this and you multiply it by both sides, basically what you get is a angle equal to what these values would be.
Right. So we're just gonna cut it short here.
Okay, so we're just gonna get angle A is
And then
equal to
we'll
x.
pick this up.
So let's try to give an example of a triangle in physics. So let's say that you threw a ball about 10 meters per second, 30 degrees from the ground. So how would you figure out what are the subsequent components of this angled vector? A vector is basically the arrows shown there, but we'll get to that in physics. So, well, we can see that we can try to put this into two separate sides of a right triangle. So in order to find x and y of this vector or this arrow of movement going 30 degrees from the ground, you use slope and toe, which is sine over is equal to opposite over hypotenuse, cosine, which is equal to adjacent over hypotenuse, and tangent, which is equal to opposite over adjacent. Now, since you have at least the hypotenuse to this right triangle, what you can do is sine of the angle measure 30 degrees is equal to opposite, which is x, and hypotenuse, which is 10. Now, if you looked at the chart previously, we know that sine of 30 is equal to about 1/2. So we're going to do 1/2 is equal to 10x. And now what you can do is just cross multiply, and you get 2 is equal to 2x is equal to 10. And then we can find out that x is just equal to 5. So now we know that, we just 3x. But ultimately we know that x is equal to 5. And now you can either use two different methods. You can use cosine, which is just, which is just cosine of 30 is equal to adjacent, which is y, over hypotenuse, which is 10. And cosine of 30 is roughly rad 3 over 2 is equal to, well, that's what cosine 30 is equal to. And then that'd be equal to this, which is just y over 10. And you can cross multiply, which again will net you something like this, but multiplied by rad 3. So it'd be 2x is equal to 10 rad 3 divided by 2, and you get x equals to 5 rad 3. Or simply, you could just use Pythagoras theorem.
Pythagorean.
You get y squared is equal, y squared plus 5 squared is equal to 10 squared. Now you just square these, and you get y squared is equal to plus 25 is equal to 100. Then you subtract 5 from both sides, so you get y squared is equal to 75. Then you square a root, and so y is equal to the square root of 75, which should roughly be equal to this.
Yeah, it's square root of 25 times square root of 3 to square root of 25 is 5.
So basically you have 3, 25, and then that's just 5, 5. So that basically would be y equals to 5 rad 3. That's the magic of trigonometry.
And yeah, so it's moving 5 meters per second squared up, and then 5 rad 3 meters per second across. And those components make up 10 meters per second in this case.
So what are the other trigonometric functions? Well, there's really just the opposite, or what we can say is the inverse. So that would be taking any of these and then putting them under 1. And so what you would get is basically just a reverse of the original. So if you have tan, it'd be 1 over tan, or adjacent over opposite. For sine, it'd be 1 over sine, or hypotenuse over the opposite. Or cosine, or 1 over cosine, would be the hypotenuse over adjacent. And this is just a translation of what they would be named for the inverse. So tan would be cotangent, sine will be cosecant, and cosine would be secant. And if you remember from over here, trying to figure out what this angle measure would be alone, you could use the inverse with this regular trigonometric function to find what that value would be. Over here, this is just a reference to what each trigonometric function would look like when graphed, and each value placed on the x-axis would be a value correlating to a radian. So as you can see, this is up to about pi over here, no, 2 pi over here, and this would be pi. But that's something that you don't really need to know for now. Well, it's just nice to look at too. So, are there any questions?